So, in order to re-establish the equation cone volume equals to 1/3 pi r square h using no calculus, we have in figure 1 shown a right circular cone with base radius of r and vertical height h in three-dimensional view. In figure 2, we have shown the front elevation of the same right circular cone, as you can see, and it is geometrically depicted as APQ, O being the projection of the center of the base circle. In figure 3, for the convenience of geometrical manipulation, we have shown half of the cone as APO, and we have considered a radius RY as ST at a height Y from the base. Now, since triangles AST and APO are similar, we can write from figure 3 between triangles ATS and AOP that RY upon R is equals to H minus Y upon H, since ST by OP is AT by AO, from which we can write RY equals to R into 1 minus Y by H. So we can write Rj equals to R into 1 minus J minus 1 into H upon N into 1 by H. H and H cancels out, leaving us R into 1 minus J minus 1 upon N. Now, as a worthwhile prelude to writing this equation, we must explain the total concept. Let us conceive that the entire height small h of the right circular cone is divided into n number of very thin discs. That is, n is a very large number and h is divided into such equal thin discs. So since there are n number of discs equally dividing h, thickness of each of the discs is h by n. And now let us consider the jth disc, sequentially the jth disc from the bottom. So since it is the jth disc, naturally there are j minus 1 discs beneath it, so it stands or sits on a stack height of j minus 1 discs, each h by n thick. So the stack height is j minus 1 into h by n. So in this equation, y is replaced by j minus 1 into h by n, and thus ry is replaced by rj, and we can write r into 1 minus j minus 1 into h by n into 1 by h, that is r into 1 minus j minus 1 upon n. Thus, we have got an expression for the radius of any such thin laminar disc located at any arbitrary height from the base. Say it is the jth disc. it must be understood that J can have any value ranging between 1 to n. Now, we shall proceed to find out the volume of such a disk. Well, let it be the jth disk itself. Naturally, the volume of the jth disk will be area of the jth disk multiplied by the thickness, that is pi into rj square, that is the area of the disk, multiplied by the thickness h by n, because all such disks are only h by n thick. So it is equals to pi r square into 1 minus j minus 1 by n whole square multiplied by h by n. Now this we expand, this whole square formula we expand, and we get pi r square h by n into 1 minus 2 into 1 into j minus 1 by n plus j minus 1 upon n whole square. So that gives us pi r square h by n minus 2 pi r square h upon n square into j minus 1 plus pi r square h upon n cube into j minus 1 whole square. So, having thus found out the volume of the jth disk, we conclude that the entire volume of the cone will be the summation of the volumes of all such individual disks, that is, of all the n disks comprising the entire cone, each of which are equal in thickness but differ in radii. However, we have also found out the general relation giving the radius of the disk in terms of its height from the bottom. So the total volume of the cone will be the summation sigma j1 to n of pi r square h by n, that is the first term, minus 2 pi r square h by n square into sigma j ranging from 1 to n of j minus 1 and then plus pi r square h by n cube into summation sigma j ranging from 1 to n of j minus 1 whole square. So long we have found out the volume of the jth disk. So the entire volume of the cone will be the summation of the individual volumes of all such individual disks, that is total n number of disks, each of which are equal in thickness but are different in radius. So total volume of the cone will be summation of pi r square h upon n, j ranging from 1 to n, that is the first term, then 2 pi r square h upon n square into summation of j minus 1, j ranging between 1 to n, and third term is pi r square h upon n cube sigma j equals to 1 to j equals to n of j minus 1 whole square. Now, for the sake of convenience, let us designate the first indicated summation by S1, the second indicated summation by S2, and the third indicated summation by S3. So, calculating each of the summations individually, S1 is equals to pi r square h upon n, and n such, that is 1 plus 1 plus 1 up to n terms. So that gives us you pi r square h. Now coming to S2, it is 2 pi r square h upon n square into j minus 1. So it is, when j equals to 1, the first term becomes 1 minus 1, that is 0. So 0 plus 1 plus 2 plus 3. We see this is the summation of the first n minus 1 natural numbers. Because the first term is 0, so it is not up to n terms but n minus 1 terms. So summing up, we shall get pi r square h using the formula n into n plus 1 by 2. That is the familiar summation formula for first n natural numbers, only n minus 1 replacing n. It is pi r square h upon n square into n square minus n. Similarly, calculating S3, it is found that pi r square h upon n cube into j minus 1 whole square. When j equals to 1, then 1 minus 1 is 0. So the first term becomes 0. So it is 0 plus 1 square plus 2 square plus 3 square plus 4 square, like that up to n minus 1 terms. Why n minus 1 terms? Because the first term is 0 and will contribute nothing to the summation. So it is the same formula, familiar formula, we are going to apply for the square of the first first n natural numbers, that is n into n plus 1 upon n into n plus 2 upon 6. So that formula we are applying, but only n minus 1 replacing n. So that gives us pi r square h upon n cube into n minus 1 into 2n minus 1 upon 6. So n cube and n cancels out, leaving n square in the denominator. So the total expression for the entire volume of the cone is S1 minus S2 plus S3, that is pi r square h minus pi r square h into n square minus n upon n square plus pi r square h into n minus 1 into 2n minus 1 upon 6n square. Taking pi r square h common, we get 1 minus, within bracket 1 minus 1 by n, and then plus 1/3 minus 1 by 2n plus 1 by 6n square. So that is for the third member. Now taking off the brackets, we get pi r square h into 1 minus 1 plus 1 by n plus 1/3 minus 1 by 2n plus 1 by 6n square. Now we conclude that n being a very large number, any member which is having 1 in the numerator and n or higher powers of n in the denominator will be negligibly small. So we neglect 1 by n, 1 by 2n and 1 by 6n square. And 1 and 1 has already cancelled out, so leaving only 1/3. So that gives us pi r square h into 1/3, that is 1/3 pi r square h, which is the expression for the total volume of the cone. Thank you.